All right, so today we are going to start into chapter 5, which is on the integumentary system, which is basically skin. And we are going to walk through all the things that are listed here for your skin. So we're going to talk about what are all the functions of your skin. And these are things that you may not realize your skin is doing. So we have a lot of functions that we'll walk through. And then when we use the term skin, we're actually talking about an organ that's on the surface of your body, and it has 3 very different layers to it. So the very top layer is called the epidermis. The epidermis is made of epithelial tissue. So remember when we talked about epithelial tissue in the last chapter, I told you that it has no blood supply, but it's very vascular, but it's very innervative. It has a great nerve supply. So your epidermis is made of epithelium. So that's on the very surface. Just under that, we have our dermis. The dermis is made of connective tissue. And then just under that, we have the hypodermis, and the hypodermis is made of fat. So we're going to walk through each of those 3 layers. We'll talk about the tissues in there. We'll talk about some of the different kinds of cells and some of the characteristics that we find. I think it's easy to remember the 3 layers, right? Because epi means above or on top. So the epidermis is sitting on top. Then there's the dermis, and then the hypodermis, right? Y'all should know what hypo means. Remember in chapter 1, we talked about our abdominopelvic regions and how we have the hypochondriac region, which means below the cartilage. So hypo just means below the dermis, hypodermis. We will also talk a little bit about skin color. So what gives your skin its color or its tone? Now, we're not going to go over all the pigments that we find, but I am going to mention the 3 most common pigments that really tend to give your skin a lot of color and tone. And then towards the end of the chapter, we'll also go through a couple of things, like we'll talk about some of the glands that are in your skin. We'll also talk about some disorders that can affect the glands, right? I mentioned to you in the last chapter how we have oil glands, and because of the type of gland that we have with an oil gland, it's a holocrine gland, where you've got the whole cell bursting. You got a lot of stuff coming out of the duct, that it's very easy for those to get clogged. So we'll talk about things like acne. We'll also talk about things like sebaceous cysts. So we'll talk about some issues or homeostatic imbalances with some of our glands. We'll also talk about hair and hair follicles. So I always think this part's kind of interesting. We'll talk about why, like, the hair on your head can get really long, but your eyebrows stay pretty short. We'll also talk about nails as well. And at the very end, we'll talk about skin cancers, different types of skin cancers. I think we all probably know someone who's had skin cancer, or maybe you've had it yourself. And so skin cancer is super common. We'll talk about that. And we'll also talk about burns, different kinds of burns, like 1st degree, 2nd degree, and 3rd degree. And I mentioned this in chapter 4, tissue repair. We didn't talk about it in chapter 4. I told you I kind of moved all of that into chapter 5, so we'll touch on that here. Okay, so that is what we're going to talk about in chapter 5. I mentioned that we're going to start with functions of our skin. So the reason that we say our skin is the integumentary system is the term integument means covering. And all of the functions that are listed here are functions that your skin provides. So we're going to go into detail for each one of these. Now, the first one that's listed up here, protection. Your skin actually provides you with 3 forms of protection, right? So one form of protection is a chemical protection. So a chemical protection is that your skin is actually either secreting a chemical that's protective, or there's a chemical inside the skin that's protective. So the secretions, one of them is called the acid mantle. This one is just like what it sounds like it is. It is an acidic secretion. And it actually causes the pH on the surface of your skin to be low, right? An acid has a low pH. If we think of our pH scale, which runs from 0 to 14, right? 7's in the middle, that's neutral. An acid is on the low end of the scale, and a base is anything above 7. So an acid's below 7, a base is above 7. So the acid mantle has a low pH. It's secreted on the surface of your skin, so it's all over the surface. And this is actually super helpful. Bacteria, think about them, they're living organisms, and they're like little people. They thrive in a very particular environment, just like we do, right? We can't live in an environment that's super hot or super cold. Same thing with bacteria. If they're living on the surface of your body, there's a lot of things they prefer. They prefer a normal human body temperature of 98.6. They prefer a very neutral environment because the majority of our body inside is neutral. So by secreting an acid mantle, we're actually making this an inhospitable environment for a lot of bacteria. So it cuts down on the bacteria that would otherwise inhabit the surface of our skin. Another secretion are secretions that we term bactericidal substances. So that term bactericidal, right? I always think like suicidal. So bacteria and cidal, which is killing or deadly. So these are substances that kill bacteria. They're deadly to bacteria. And there's 2 of them that are secreted from your skin. One is called human defensin. This is a super cool chemical that gets released. It is not specific. So I'll write that over here. Not, here my pictures are in the way. There we go. Not specific. That's not how you spell specific, guys. I can't talk and write at the same time. I struggle with that. All right. This one's not specific, meaning that it is not targeting any particular bacteria. It's just anything that doesn't belong. What it does is it punches holes in the plasma membrane of that bacterial cell, and it causes it to burst. It causes water to rush into the cell, and it bursts open. So it causes the cell to lyse open. Another one is called cathelicidins. Cathelicidins. Now these are specific, and notice that I have right here what they're preventing. They're preventing streptococcal infections from growing on the surface of your skin. So a lot of these secretions are things that we're going to talk way more about in Anatomy 2 when we do the immune system, because your skin truly is your first line of defense from things getting into your body. So having this acid mantle, secreting human defensins, secreting cathelicidins, these are all things that are keeping infections at bay on the surface of your body, which also means that it's going to keep things from getting into your body. Now, another one is, another chemical protection is melanin. Melanin is a pigment that actually protects against UV rays. And I'm going to open up a little whiteboard up here so I can draw. And so typically what will happen, can you all see my whiteboard?
Yep.
Okay, great. So typically what happens, if we think about just the cells in our body, right, they have a nucleus, okay? And our skin cells also have little vesicles in them filled with melanin. Melanin is a pigment. It's typically a dark pigment. And so we have these little melanin vesicles kind of all over the cells. And what happens is when you are out in the sun and the UV rays hit your skin cells, the melanin vesicles will migrate to the sunny side of the nucleus. So they'll migrate like this. And they basically form a little umbrella on top of the nucleus. And what they're doing is they're shielding the nucleus from UV rays. And so when the UV rays hit the nucleus, they bounce back off. Or when they hit that melanin umbrella, they bounce back off. So it's a great way for your body to protect your skin cells from UV rays. We know that all forms of radiation damage living tissues. So if UV rays hit the DNA, inside your nucleus is DNA. If the UV rays hit the DNA, it causes the DNA to mutate. I want you to think of DNA as sort of like the instruction manual for your cells. It tells your cells everything they need to know, how often to divide, what kind of proteins to make. And so if the instruction manual gets rewritten, if UV rays change the DNA, change the instruction manual, it can cause the cells to divide too fast. And that is what leads to things like tumors and cancer. And so by having melanin in there, which migrates to the sunny side of the nucleus and shields your nucleus from UV rays, you're protecting your DNA from getting rewritten. So it's a pretty cool thing that we have in our skin. Now, melanin is a dark color. So this is why when you go out in the sun and you are not wearing sunscreen, this is why you get a tan, because your body not only makes more melanin so you can protect against UV rays, but that melanin is moving to the surface of all of your cells. So it's going to make you appear darker in color. Okay, so that's how we get that suntan. All right. Oops. I didn't mean to stop sharing my PowerPoint. There we go. Another kind of protection other than chemical is a physical protection. So your skin is a great physical barrier, right? It's continuous all over the outside of your body. And so it has continuity. In fact, if your skin gets cut, it heals super fast. And even if you have a deep wound or a deep cut, your body will create a scab on top of it, which is essentially like a human Band-Aid. So even before it's healed, your body is still trying to make this physical barrier continuous by creating a scab. So you have this nice continuous barrier. The other thing is that your skin is waterproof. So that means that, you know, when you take a bath, if you're sitting in the water, you're swimming in a pool, water is not moving through your skin. Your skin has a lipid coating in it, which is waterproof. And that's important because if you sat in a bathtub or you went to a swimming pool, if your skin weren't waterproof, you would absorb all that water and you would get huge and puffy, and it wouldn't be good for anybody. Now, I will tell you that this waterproof coating in our skin is not foolproof. There are some things that can get through the waterproof coating. Obviously, gases like oxygen and CO2, those can move back and forth across our skin. Now, this is not how we're getting oxygen into our bloodstream, but you can move gases back and forth. Other things that can make it through that waterproof coating are things like poison ivy oil. This is why when you brush against poison ivy or poison oak or sumac, you get those blisters because it's made it through that waterproof coating. Organic solvents, this would be things like acetone, right? We all know what acetone is in, ladies, fingernail polish remover. You ever notice that if you use pure acetone to remove your fingernail polish, your cuticles will get really dry? The reason is because acetone dissolves that waterproof coating. It dissolves the lipids that are in your skin. And so that's why your cuticles will get real dry when you use an acetone nail polish. You're just dissolving the fats that are in your skin. Heavy metals like arsenic, those can make it through your skin. And then even some drugs can go through your skin, right? There are some drugs that can do that. And so this is how we can have drug patches, right? So for example, there's a birth control patch that women can put on their hip and wear for a month, and the progesterone and the estrogen can go right through that waterproof coating into the body. So there are some patches that work that way by allowing drugs through. So you do have continuous barrier. It is waterproof, but I do want you to know that waterproof coating is just not foolproof. We also have our last kind of protection is a biological protection. The word biological means living. So we have a living component inside of our skin, the cells, that are very protective. So the cells that are protective are Langerhans cells. These are similar to white blood cells. Lymphocytes are white blood cells. I'll write WBC up here. And their job is to respond to a foreign antigen. So let me explain what this means. We have on the surface of all of our cells, we have a sugar coating. We call this a self-antigen. And this is how your body recognizes what belongs, is if that sugar coating is a self-sugar coating. All of your cells look the same. Now, we all have different self-antigens. Like mine are going to look different from Andrea's and different from Jason's. They're all different, right? And so this is why if, let's say, I needed a kidney and Jason was a pretty good match and gave me a kidney, it's not going to be an exact match to my self antigens. So I might recognize it as foreign and try to fight it off. So this is how people can reject transplants, right? And so your lymphocytes, these white blood cells, they're going to respond to any sugar coating, any antigen that's foreign, that doesn't belong. And so that's really important to have right in our skin. We have this great barrier right here. And so you want some protective white blood cells in here so that if something were to make it through your skin, they're going to recognize it as foreign and they're going to fight it off. And we'll talk way more about foreign antigens and anatomy too when we do the immune system. Another kind of cell are macrophages. We say these are your second line of defense. So what that means is that, let's say you get a cut and a foreign antigen, like a bacterial cell, is able to make it through your skin and avoid Langerhans cells. That's your first line of defense. Well, thankfully, we have a second line of defense, and those are macrophages. Macrophages are these incredibly voracious phagocytic cells. They gobble up foreign organisms. And so they are our second line of defense. So if something makes it past your Langerhans cells, you have macrophages to try to fight them off. So these are great protective mechanisms in our skin, protecting us from getting sick. And then lastly, we have DNA. Now I know this one's gonna sound weird because I just told you that when UV rays hit your DNA, they can rewrite the instruction manual. But DNA also has the ability to absorb UV rays and dissipate those rays as heat. Now, that's not to say that the DNA can't get mutated. It can, but it can also bring it in, absorb it, dissipate it out as heat. By doing this, cells on the surface of your skin are actually protecting the cells in the underlying layers. So that means that, you know, if you don't have enough melanin, or maybe your melanin is really light in color, like my melanin is really light in color, then you're not as protected. And so that DNA will absorb the UV rays, dissipate it as heat, and protect the underlying cells from having damage. Okay, so those are all some biological protections. So those are our three kinds of protections, right? We have chemical, we have physical, and we have biological. Now, another big function of our skin is that it can regulate your temperature. And it does this by constricting or dilating the blood vessels in your skin. So when it's really hot outside, your blood vessels will dilate. Whoops, I don't know why that happens. So when a vessel dilates, it means it gets nice and big. And so when the blood vessels on the surface of your skin dilate, a lot of times your skin will get warm to the touch. It'll also get flush, right? Like your cheeks would get flush and get more red because you're pumping more blood to the surface of your skin. And you're doing this to help evaporatively cool your body, right? You're also sweating. So your skin is sweating to help cool you off as well. Now the opposite happens when it's cold. When it's cold, your vessels in your skin will constrict. So that means they're going to get really small and narrow. And what you're doing is you're shunting the blood away from the surface of your body and keeping it in your core, like in your body's trunk, so that you can keep your vital organs at body temperature. So this is why when it's really cold outside, the first things in your body to get cold, or even if it's super cold to get frostbite, would be fingers, toes, Your nose a lot of times gets really cold, and so do your ears. So it's all of your extremities that would get super cold, and that's just because you've constricted all those vessels and you're keeping your warm blood in your core, not your extremities. Another big function of your skin is sensation. So you have a lot of receptors in your skin that pick up different senses and different stimuli. And we call these exteroceptors. So that just means external receptor. It's going to pick up an external stimulus. So we have a couple that are listed here that we find in the skin. One is called a Meissner's corpuscle. A Meissner's corpuscle, where we find it, is very close to the surface of your skin. So it's going to pick up things like light touch or light pressure. We also have Merkel discs. Merkel discs, these are also going to help pick up light touch, light pressure. A lot of times these are associated with a deeper nerve, so they're making sure that the nerve stays healthy. A Pacinian receptor. These are located much deeper in your skin. So for these to pick up touch, it would have to be a harder touch. It would have to be deeper pressure for them to pick that up. So these are going to pick up, I always remember Pacinian starts with P, so I remember pressure. So these pick up more severe pressure. You also have some receptors that wrap around your hair follicles so that when your hair moves, you recognize that. So this is how you're going to pick up things like wind. Wind usually does not have enough pressure to activate a Meissner's corpuscle or a Pacinian receptor, but it causes your hair to blow. It causes the hair on your arms to move or the hair on your legs. So this is going to pick up wind. It is also going to pick up pests. So, you know, there are times where I might feel my hair move, right? Like maybe the hair on my arm, and I'll go like that if I'm outside because it's probably a mosquito, right? Mosquitoes are so light that they're not going to activate any of those light touch receptors, but they will cause the hair to bend and move, and you'll pick them up that way. So maybe spiders or mosquitoes or gnats, that's how you're identifying those on your body. So wind and pests. And then bare nerve endings. These are going to pick up pain. Okay, so these are some different receptors that will pick up different kinds of sensation in your skin. Another big function of your skin is that it has a metabolic function. Remember, your metabolism are reactions that are happening inside your body. So there are reactions that are happening in your skin. I write reaction like that, just for short, reaction. Some reactions that are happening in your skin. The first one, making vitamin D, right? Your skin makes vitamin D. What do you have to have for your skin to make vitamin D?
Sun.
You gotta have the sun, right? So you have to be exposed to sun for your skin to make vitamin D. So I'm gonna do it like this. You gotta have sun for your skin to make vitamin D. And then what do you need vitamin D for?
Calcium.
Yes, you need it for calcium absorption. So there used to be a commercial for a calcium supplement which showed like a key with a D at the end. And so they would always say that vitamin D unlocks your calcium. And I love that commercial. I love that imagery because that is absolutely true. Most of the time, if you're taking a calcium supplement, what you're going to notice is that that supplement has not only calcium, but also vitamin D in it. Because honestly, you can't absorb calcium if you don't have vitamin D. So people who are shut-ins, people that never go outside, that never see the sun, they can develop a condition, an imbalance, where their bones become really soft and weak. This is a condition called osteomalacia. You don't have to remember this now. We're going to talk about it later on in the semester when we do bones. But that's a great example. If you don't see the sun, then you're not making vitamin D, and you're not able to absorb calcium. And calcium, we know, helps to make our bones hard. It's one of the things that it does. So your skin makes vitamin D. In fact, we all wear sunscreen. Hopefully, we all wear sunscreen. It's important to do that. But what a lot of research has shown is that I have light eyes. So a lot of times if I'm outside, I have on sunglasses. And what a lot of research has shown is that how your body knows you're being exposed to the sun is through your eyes. And so they say if you are always wearing sunglasses when you're outside, you may not be producing enough vitamin D because your eyes aren't telling your brain that you are being exposed to sunlight. So it is important to take your sunglasses off, not for long, but just for, all you need is like 5 minutes a day. That's it. So it's not a ton. You don't need, I'm not telling you to go outside with baby oil on and hang out in the sun, get a suntan. It's just walking to and from your car, walking to your mailbox. Those are things that would provide you with enough vitamin D. Another metabolic function of your skin is that it can activate some hormones, things like hydrocortisone. And then also it can make proteins like collagen or collagenase. And we know collagen is that really tough protective fiber that's really, really strong. So all of these things are made by the skin. And then one of the last, well, not the last, but one of the last functions of your skin is that it's a blood reservoir. Right? Think of the term reservoir. Right? A reservoir would be like holding water. Well, your skin is holding blood. Your skin can hold up to 5% of your body's blood volume. So we have about 5 liters of blood in our body, and our skin can hold about 5% of that. And what's going to happen is if another area of our body needs blood, our vessels will constrict and get small and shunt that blood where it needs to go, somewhere else. So the vessels in your skin get really small so that the blood can travel somewhere else in your body where it's needed. All right, and then I think this is one of the last ones. This is excretion. So you are actually excreting things from your skin, not in the way that you think of when you think of the word excretion, but there are things coming out of your skin. Nitrogenous waste. This is the same stuff that you find in urine. So like urea, there is a little urea that comes out from your skin. It's coming out from your sweat glands. Obviously, other things that are coming out from sweat glands are things like water and salt, right? Sweat tastes salty. Other things that you might excrete would just be byproducts that your body doesn't need, right? Someone who eats a lot of garlic, a lot of times their skin might smell kind of garlicky, and that's just that byproduct of what they're consuming. Alcohol. I used to have, she's passed away, but I had an aunt that was an alcoholic and she drank all the time. And even if I would see her and she would be sober, she would smell like alcohol because it's coming out from your skin, right? So your skin does excrete. So those are our big functions of skin.